Welcome to this session. Just a quick question. How many of you use the cloud at work today? Okay, so for the others, how many of you use Dropbox or Box or Netflix or Spotify or Airbnb? There's somebody who never raised their hands. I can't believe it, right? So the cloud is everywhere. All these applications and many more, they use the cloud. They are in the cloud. Many of them, they use AWS actually. Tableau uses AWS as well. AWS is the leader in the cloud computing market. Now, today, it holds about 1/3 of the market, of the cloud computing market. It has more than 1 million enterprise active customers. It's deployed in more than 200 countries. It's really the leader. Tableau has a strong partnership with AWS. You can Google where our CEO comes from as well if you're interested. But we as consultants, we see this trend applied to analytics more and more. So more and more organizations are moving their data or their infrastructure to the cloud. So we see it as solutions consultant. We are both solutions consultant based in London. Actually, Marius was supposed to put a funny picture of himself. He didn't. So that's me.
I think that's pretty funny. And while you were busy looking through all your teenage photos, I was watching the World Cup probably.
Yeah? How'd it go? I wasn't watching it. Italy.
Not too well. Not too well. Let's go over to the cloud.
Yeah, all right, yeah.
The Germans in the room will feel my emotions. Cool. Yeah, we're gonna focus on the cloud today, and it's the cloud is really a main driver of modernization of IT infrastructure and digital transformation. And as Michele said, we see that day in, day out now at Tableau as well, because we're part of that ecosystem. And more businesses find cost savings and value in the cloud. So that's, I guess, why you are here, interested in the cloud, or already deployed in the cloud and want to find out what the best ways are. But and then from a Tableau side, from a Tableau point of view, we have different flavors how you can make use and leverage the cloud. So as an alternative to on-premises servers and data centers that are pretty hard to build up and very costly to build up, you can deploy in the cloud, leverage the cloud with your servers on the one side, the infrastructure, and make use of analytics. And that's the key bit that you can use in Tableau. So if you're using Tableau Online, probably your favorite analytics platform in the cloud. Who's using Tableau Online here in the room? All right. Quite a few. Great. So this is already the cloud, right? You can easily set up a Tableau Online site and already start sharing your content within a couple of minutes. So that's a great way to leverage the cloud.
And Tableau Online is partly on AWS as well.
Exactly. Yeah. So even recently we created a new pod, we call them, on AWS here in Europe, right? Yeah. So that's a very important point as well to stress for European customers. And then on the other side, you can spin up servers and instances in the cloud and then install Tableau Server on it, right? So you have full control over it. You can do that on AWS, Microsoft, Azure, or Google Cloud Platform. It's your choice. But if you get it started, it's quite a jungle out there if you get started with the cloud, right? You have so many different services and features. Where do you get started, right? So that's our goal for this session, to guide you through that, be the guide, and be your guide and talk you through the main components, main services that you should look at in terms of analytics and Tableau. And we're going to show you some use cases as well around those features and services. So mainly this session is split up into two main parts. One is analytics, very important, right? When we have data in the cloud, we want to run analytics in the cloud. How do we do that in the best way possible with Tableau? And then on the other side, we have the infrastructure if we want to run in a server in the cloud on AWS in this case, and want to share content quickly on that server. So by the end of this session, you will be able to navigate, you know your way around the management console in AWS. You will be able to use and to find the most common services for data analytics, and you will be able to deploy a Tableau server on AWS. You will see how easy that is. With our goal to make you feel confident to get started with AWS very easily and quickly. What this session is not about, it's not a very detailed AWS training, for instance, right? We're going to cover a couple of services, but not everything. That's simply not possible in just 1 hour. And it's not a deep dive into big data or AWS architectures. We're going to cover it a little bit. And then it's not a hands-on workshop. We're going to give you good actions at the end where you can get started and play around with yourself. We really encourage you to do that, actually. But you can't follow through all the steps, right? Because we want to cover a lot of ground. All right, so what I want to know is, how many of you have data already in the cloud somewhere? Wow, that's actually a lot. That's roughly half the room.
Yeah. Okay, so actually, how many, before we move to the next slide, how many of you have hands-on experience with AWS? How many of you have opened the console, for instance? That's the first thing that you find when you browse to the AWS. Okay, that's about half of you. Okay.
Yeah, that's amazing.
Yeah, that's very good. And actually, just making the number, like calculating very quickly, that's about 38% of them, because I think it was about 38,
yeah,
38,
you're
39%.
pretty good with your mental math, yeah.
And then that kind of matches what we find here. So no, I'll let it to you. Sorry, I spoiled it.
So this is a cloud survey, right? Run last year by RightScale, and they found a very similar sentiment in that survey, that a lot of customers, 30% already have a cloud focus, have most of their systems in the cloud, and more than 50% are then as well cloud explorers, right? At least looking into use cases, looking into ways to leverage the cloud. And even quite surprising for me, even for enterprise customers, they are massively looking into that as well. The smaller businesses, they're a bit more agile, right? They're a bit ahead of the curve, but definitely everyone is looking into it. So it's a great session for you guys to be in. And so when we talk about the cloud, we have the 3 big vendors, right? We have Amazon as the market leader. As Michele said, we have Microsoft catching up very quickly with Azure, and then we have Google Cloud Platform as well, right? And you can choose any of these, really. We focus on AWS today, but you can choose any, because we at Tableau, we're all about choice. We want to give you choice, and you can decide which of these providers you choose to deploy in the public cloud, or you just use our servers on Tableau Online. You can choose the platform, Windows or Linux. You can leverage all the data in the cloud, right? So that can be on any of the providers as well, or even on software as a service applications. But today, we're going to focus on AWS. And I would say before losing a lot of words around AWS, let's get started right away. So if we get into AWS, we log into the management console, right? We get this. We get all the different services. It's quite scary, right? It's quite intimidating at first, I would say. Where do you get started, right? So today, we're going to cover a couple of these services, but this is the jungle I was talking about, right? It's quite tricky to navigate, and by the end of the session, you will know which are the key services, how to use them, and how to leverage them. Right? And Michele will introduce you to the analytics on AWS.
Yeah. So actually, just a comment on the 3 main vendors. Everything that you see today will cover different services. You'll find the analogy, so the kind of the matching service in the other platforms. So many times you can apply what you see today in your organization's cloud if you use Google Cloud, for instance. There's some little differences. Google Cloud is more generic than AWS, I would say. AWS, it's, from what I saw, the most complete ones with the highest number of services. But most of times you can apply this knowledge to other cloud providers. So Tableau integrates with Amazon Analytics platform, and many times is the natural choice for analyzing data that's on AWS already. So what do we know about running analytics on Amazon from Tableau? As far as I knew when I started Tableau, I knew that there were 4 connectors called Amazon something. They are Athena, Aurora, EMR, and Redshift. We'll see how to leverage other connectors. But the basic idea comes from a higher level. So if you think in the last 10 years, decade, actually in the last 2-3 years, there's been an explosion of data, of the volume of the data, of the number of data sources, of silos where this data is generated and created and collected. So it's very, very difficult, if not impossible, to analyze the data, having to go to all these different silos, especially in large organizations, right? So the idea is people now want to build the so-called data lake. That's a place where you consolidate all your data. And you know what the most popular data lake store is today? It's not just Amazon, but more specific, it's Amazon S3. S3, we will see what it is in depth, a little more in depth, but this is what they propose as a generic data lake architecture, very high level. So you have your central storage, and then you have a bunch of different services and applications built on top. Analytics is one use case of it. There are different shades in which organizations apply this diagram in practice. There are many customer stories that we share with Amazon as Tableau. Many customers have accepted to share their architecture publicly. You can actually find many of these customers, Airbnb, Netflix, Grab, and Cisco, in both websites. Let's take Netflix, for instance. This is a way that you apply that architecture. You have S3 as the central storage where you ingest the data, you collect the data, and then you have a bunch of platforms or framework like data processors, data exploration, of course Tableau, fast storage, streaming, batch, etc. And I know that many of you already feel overwhelmed by all these diagrams and animals. You see some animals around, names and arrows. So I thought I would simplify this a little more, all these diagrams. And sounds funny, but this is a simplified version. But I would say focus on the top, because these are the main components, the 4 main components that we see almost in any customer who deploys analytics on the cloud. That's collect, store, process, analyze, and consume. Of course, Tableau, it's on the consume part. This is how you consume your data. You create dashboards and visualizations. S3 is on the store part. You can see it there. We'll see some of this in the process analyze part. And the collect is the silos that I was mentioning. They can be streaming data, IoT sensor, devices, line of business applications. It can be anything. So the idea is to take these data sources, these silos, take the data and collect it as is in S3. Just don't worry too much about where the data comes from. Just take the data and put it into S3. S3 allows you to do so because it's very simple. S3, it's a object storage. It's a low-cost object storage, object-based storage. It means it stores files. That's it. There's nothing much more to say. Object sizes can range from 0 bytes to 5 terabytes. This is actually quite an important part. So we saw it's a storage for files. actually Dropbox was originally based on S3, 100%. So Dropbox was born on S3. And the files are stored in buckets. That's the only thing that you need to know. In S3, you organize your objects in buckets. One bucket can contain folders, subfolders, files. You can have multiple buckets. The good thing about buckets is that they have a unique name globally. So if I know a bucket name, I can address it regardless of knowing the region where it's deployed or any other information. I just need that bucket name. And we can discuss this later. If you want, just come to me. We can discuss the different storage classes available, how you can save money using S3. But basically, you have other options than the standard S3. So I want to show you, actually, how S3 looks like. And so I'm going to switch screen. And you remember the collect part and the store part. So for the collect part, we are going to actually use some real data that comes from this website. I don't know, probably, how many of you have seen this website before? It's becoming really popular recently. Actually, if you browse to Tableau Public, there's quite a lot of visualization built on this data set. It's the New York City Taxi and Limousine Commissions. They record every single trip for taxis in New York City. And they've collected since 2009, and you can download the data on a month-by-month basis, and it's just a CSV file. So I'm going to use data for yellow taxis, and actually this is very, very simple. It just lets me download a CSV file. So once I get the CSV files, I can go to AWS, and this is what you see when you open AWS. You see this. This is the screenshot that Mario showed you before. It's just a list of services that you can use on AWS. And we are going to use S3, that's under storage. And this will bring up my S3. So in my S3, I have a bunch of different buckets. We are going to use this one today. So it's TechSet New York City taxi data. And in it, I've loaded some files already. So they are just 6 text files, 6 months worth of yellow taxi trip data. How I did it? Well, you could just upload it manually and add files. It's really simple. The interface, it's really, really easy to use. What you can do, just out of curiosity, how I did it, these files in the New York City TLC website, they are already in S3. So they are using S3 as well. So what you can do, what I did, I use the command line interface of AWS. You can write a script, it's 2 lines, and kind of run a for cycle and just copy them over to your S3 programmatically. Is what you can do. If not, if you're not familiar with a command line tool or with the SDK or Python or anything, you can just do it manually.
Yeah, it works like Dropbox basically, right? Just drag and drop over and you got it.
Like Dropbox, yeah. I mean, actually Dropbox, was based on.
Oh, I didn't know.
Okay, so.
And the data could have any shape or form, right? Any shape or form.
I'm using CSV, it can be anything. It can really be anything. Actually, most of the time, it's not CSV, it's much more unstructured data. Yeah. So, we saw where the data came from. We put it into S3. Now, we want to see this data already, because, I mean, at the end of the day, they are CSV, and I want to be able to see them. Now, if I want to see the CSV files that are in S3 in Tableau, I have to tell Amazon, I have to tell Tableau, I have to put a schema. I have to know what columns I'm analyzing, what's the data type, are they numbers, are they string, what are they dates. So in order to do that, we have to put something in between that's called Amazon Athena. Amazon Athena, it's in the process analyze part. And with Amazon Athena, you can actually access data that's in S3 in Tableau. So it's like a bridge, more or less. And actually, more precisely, Athena, it's a serverless, so you don't have to think about the infrastructure, query service for S3 using, that uses standard SQL. So it provides a SQL interface to S3, basically. You don't have to install it anywhere. It's serverless. You don't have to worry about instances, RAM, sizing, machines. It just works. And it works actually with multiple files, not just CSV. You can use it for JSON, for Hadoop-related format, for log files. So it's very powerful. And you pay per query. You don't have an infrastructure to manage, but you pay for the data that you scan when you run the query. Actually, it's $5 per terabyte of data scanned.
So that means it could be quite expensive if I have large data volumes, right?
It could be expensive, yeah. So we'll see how to mitigate cost. Especially CSVs are not the best data type with Athena. We'll see how. But first, let's assume we want to understand this data. We want to see when people are traveling, right? So the idea is, I go back to the console. Oh, actually, I have to duplicate, sorry. I go back to the console. So you can click on Services. And now I'm going to go to Analytics and find Athena.
So these are already two services that we covered, right? And you know how to find them and how to use them, right?
So here we just have to click on Create Table. And I'm going to select manually. This is a relatively new service. I'm going to just mention it later. But I want to show you the kind of the original process behind it. And now what I have to do is to give a name to my database. Just call it TCE18. Table name, it will be New York City taxis. And this is where my data is stored. And that's in S3. If you remember, actually, it was a bucket called TechSet New York City taxi data. Can you see from, yeah, okay. Can you see James? Yeah. Okay, so I hit next. Here, quite straightforward, CSV. And here I go about defining the schema. So actually, if you're using this data, you can find a dictionary in the website. That's really handy because you find just a list of fields that are in the text files. Otherwise, you should probably know the schema if you want to analyze the data. And here, I either define them manually, so vendor ID, string, add a column, etc. Or, even better, if I know the schema, if I have a list of fields, I can bulk add columns. And here, I would go about vendor ID, it's an integer, pickup date time, it's a timestamp, drop-off time, it's a timestamp, etc. It's just a list of fields. I hit add. Athena pre-populate all my columns. Just hit next and create table. Now Athena generates some DDL code for me. I don't have to worry too much about the code. Just hit run query. And that's it, really. So now I can find my database here. You see, it's TCE18. There's a table here, New York City taxis. But of course, the good thing is that I can go to Tableau now, select Amazon Athena, input my credentials, and hopefully find the same schema that I've just defined in the console. Yeah. So let's see. I want to know how many records actually I'm analyzing. So here, just select the only option that I have. And here I can actually see TCE18. It's the one that I've just created. And I expect to see the table called New York City taxes, actually. So this is just Tableau. Let's have a look at the number of records. Just don't spend too much time on this. And now remember that I'm querying my CSV files that are in S3. And they contain about 76 million records. So actually Athena, considering that I'm working with text files, and they are in the cloud and I'm connecting with a probably normal connection, internet connection, it's quite fast. I can break it down by, I don't know, by month. Let's try break it down by month. Let's see how long it takes. So it's quite good. It's quite fast. Yeah. So now, what's the catch, right? So it's too good to be true. So a couple of more notes for Athena. The concept behind that you will hear probably many times. It's a schema on read. You will hear this concept many times. It means that I'm storing unstructured data, so I'm not using a schema on write. I'm not worrying about the schema when I write the data into my storage. I'm only applying the schema at runtime when I execute the query, only when I need to. So that's a very important concept. The query results are stored back in Amazon S3. You can reuse them. And the metadata, so the columns, the data types, are stored in something called the AWS Glue data catalog. And this is quite new. It has probably a year or more, but it's quite new. And we will see later why that is important. So we are here. We've seen S3 with some CSVs, Athena, and how to access Athena. Now there's a problem. Athena can be really expensive with CSV because CSVs are not compressed. So I have to scan them all every time that I run a query, essentially. They cost money on Athena. They cost money on S3 because they're very big, typically. And they are slow compared to other formats, especially Hadoop-based file format. I'm thinking of Parquet. How many of you have heard about Parquet before? Yeah. So this can be a good data file type for running queries. Another example is Orc or Avro or these type of files. If you don't know what they are, it's just a columnar data store. It allows me to only query the column that are really relevant to my query. So that means scanning less data in Athena. They are compressed, so they are less data inherently, and they waste less space on S3. So it means cost savings. If you project that at scale, that can be significant. So we don't want to use CSV files, we want to use Parquet files in this case. And one of the problems about Athena is that it can't write back. It cannot write back to S3. It cannot process data. I cannot use Athena as ETL. I cannot. It's just an interface for exploration. It's a really good one. But then, ideally, I want to get some action from my initial exploration and do something with my data. Otherwise, it's too expensive. So you can use Tableau Prep, for instance, from here. That's a very good option. Amazon actually offers also something called EMR, which I can use to process my data and actually much more. Because EMR, it's a managed Hadoop framework. It's the acronym for Elastic MapReduce. It is just a service on AWS. It runs on EC2 instances. It can auto-scale. Compared to the on-premise Hadoop, if you're familiar with on-premise Hadoop, it decouples compute and storage. And so it looks something like this. It looks something like something that can work with multiple storage. I'm going to use it with S3, but you can use HDFS. You can even use unstructured data sources like DynamoDB or Redshift Glacier archiving, etc. Now, just to scare you a little more, you have the whole Hadoop ecosystem available, right? So you have a bunch of animals on top that you can put. We are going to use Hive and Presto today. We're going to use Hive because it's good for processing data, for transforming data. So we can use Hive as our transformation phase. And also uses HiveQL, which is a SQL dialect. So if you're familiar with SQL, Hive is probably a good choice. And then we are going to use Presto for accessing our data. I don't know how many of you have tried to use Hive with Tableau before? Raise your hands. How's, have you tried actually, how is it, how did you find, in one word?
It was a while ago, it worked, but Hive alone is quite slow, so we didn't really...
Perfect. So that wasn't planned, but yes, it's like that. So you can connect to Hive. You have some use cases, especially troubleshooting. So you want to see what's going on at a certain stage of the pipeline. So you can connect to Hive from Tableau. You don't want to do interactive analysis with Hive. You don't want. Just by its nature is not designed for interactive analysis. It's good for other things, like transforming data. But Presto is a good alternative. So, just for you to see how would running a Hadoop cluster in AWS would look like, you can go to, where is it, Analytics, EMR. I have a cluster already, but if you had to create one, you just give it a name, my cluster. You can actually select what Hadoop services and application you want to deploy. So in my case, I would choose Hive and Presto and test. I'm not going to go into details for Hadoop. Just come to me if you have any question on any of these services. And a very important option, I'm going to use the same AWS Glue data catalog for both Hive and Presto. This is very important. So I hit next. I run one master node, two core nodes, two task nodes. Again, I'm not going into details for this, but essentially you can run 1,000 nodes and you hit next and you create the cluster and you can literally create 100 nodes Hadoop cluster on AWS in about, this would take on my machine, well, my machine, it's AWS, so around 5 minutes or so. So it's really powerful. I'm not going to do it now because we're not going to wait 5 minutes because I have it and I already have it here. So this is my cluster. From here, I can log in into my cluster using the public URL. Oops. And I can go to any kind of terminal and use my private key. I'm not going to do anything, just want to show you that the idea is that you log in from the command line and from here you can run Hive, you can run Presto, you can run anything from here. So what I did actually was running Hive and store my data back into Parquet. So it's the same data, just in Parquet now. And then you have a bunch of use cases for using EMR with Tableau. Like one can be Hive for troubleshooting, but also you can have data scientists exploring data using Presto and then using Spark machine learning that's running on my cluster. They can create notebook using Jupyter. I mean, it's Hadoop. So you can have a lot of use cases. And Tableau works very well with EMR as well. And if I had to connect Tableau to EMR, probably you already can imagine that I just select EMR. And I can connect to Hive, for instance. And here on Hive, I'll show you what I created. So here I expect to see a new schema that I've created for Parquet. This is all about internet. There you go. I've created this one, New York City Taxi Parquet. You can see TCE 18, by the way, because they're sharing the AWS Glue data catalog. So I've defined that in Athena, if you remember. But now I'm going to use Parquet. And in Parquet, I have a table that's just called New York City Taxi. That's exactly the same data. It's just stored in Parquet files. If it loads. Okay, so while it loads the table, it used to be faster, okay. Now this is just the table that I've created. So it's New York City Taxi, Parquet, and here I will see some fields. You see that Hive is much slower than Athena already, just by loading the metadata, right? But this is exactly what I had. What's much better than using Hive for interactive analysis is using Tableau connectivity to Presto. Presto has become popular in the last few years. It's a distributed SQL engine for interactive query designed for low latency queries. It works in memory. It's an open source project, so I encourage you to check it out. But here I'm connecting to Presto. One other thing that's good about Presto, it provides a web interface. So here I expect to see the same schema. It's called New York City Taxi Parquet. And here I expect to see my table. Huh? I'm running late.
No, but typical Italian.
Okay. So I'll just show them Presto, okay,
All
very
right,
quick.
Go ahead.
Okay. And Presto, he has a web interface. So now I'm connecting to Presto from Tableau. And in my browser, oh, sorry. I hit the freeze with my knee. Okay, so I'm connecting to Presto. And from the browser, Presto actually gives you this little interface. So the cool thing is that I can go to Tableau, click on number of records, go back to the web interface, and actually it was instant, so I didn't see it. But if I had to include, let's say, payment type, I can go back to Chrome, and you can actually see the query running, the SQL code, and the cluster status in real time. So Presto is actually really good. And Tableau's connectivity to Presto is really good as well. So I encourage you to check it out. Now, I'll go very quick. We're here, right? Typically, the most common use case for Tableau is interactive analysis. So I can use Presto, but what's better than an analytical data warehouse that's designed for scaling the number of users, the number of queries. It's designed for large volumes of data, for parallel processing. Amazon offers Redshift. Redshift is Amazon analytical, fully managed, petabyte scale data warehouse. It's relational. You can use SQL. It has massive parallel processing. It's fault tolerant, etc. It's really good for Tableau use cases typically. And the idea is that as data warehouse, I have to put data into it, I have to load it, and I can do it using Hive, for instance. Hive can do batch processing and load a data warehouse. That's a good use case. I can do it in any other way. I have to put data in it anyway. And then my user can just connect to Redshift and read the data from Redshift. So what I did, again, if I go back to the console, you can go to Redshift. That's under database. And again, in 2 minutes, around 2 minutes, you can launch a Redshift cluster, single node or multi-node. It's really powerful. In my case, I have a cluster that's called TC cluster. Okay, and here I've created an aggregated view of my trips on a daily basis. So it's not on the trip ID base. It's on a day-by-day base. And I mean, at this point, there's no much to wonder what's going to happen, because again, Tableau and Redshift, they have been used for a long time now. So actually online you can find quite a lot of resources on how to optimize Redshift for Tableau, how to apply best practices of performance on Redshift by Tableau, etc. There's quite a bunch of resources. Yeah. On the Tableau website, yeah. Or also on Amazon. I have a slide at the end. There's a link to AWS, and Redshift has a specific section. Yeah. So here I've just created a daily view on Redshift, and at this point I can run the trip count by year, for instance, or by month. So let's convert it to discrete. So one difference with Athena is that probably, and again, it's very quick. Redshift, actually, you have to manage the infrastructure. So you have to decide how many nodes do you want. You have to decide the type of nodes that you want. It's not serverless. You actually have to control the infrastructure. It's good and bad. It's a proper data warehouse. One very last thing. I'm going super quick. But Redshift also offers Redshift Spectrum. That's like Athena. It's just offered by Redshift. So I'm not spending too much time. Just my recommendation, if you already have Redshift, take advantage of the fact that it has Redshift Spectrum. It's exactly like Athena. You can define a schema and query data that's in S3 without bringing it into the data warehouse. If you don't have Redshift and you just want to explore the data, use Athena instead. That's my personal recommendation. So we have seen something like this. All of this, and I'm going super quick on this, using Amazon Glue. Amazon Glue has a metadata catalog where it stores the table information, the column information, everything that I've defined. It's shared through Amazon Glue across multiple services in one account. So Redshift, EMR, Athena, more services can share the same data catalog in AWS. Just one unified place where I put my table definition and column definition, and it's really, really good. It's powerful. So, am I late? How much?
Just a little bit.
Like badly.
All right.
Okay.
So that was amazing, right? So Michele showed you all the different services, how to get started, how to have analytics in the cloud. So the next step is, so that was all done from one user at the moment, right? From Michele's desktop. But we want to share this, right? The data science team want to share their results. The business wants to see their dashboards, their interactive dashboards. They might be connected to Redshift, right? And that's the second element. That's the infrastructure that we bring into this equation now. And where can you run Tableau Server? It's on EC2 instances on AWS. And we can deploy that server. I've done that with customers on 1 hour calls at some point to deploy that server, publish the first content, connect to the Redshift, to the EMR or Athena, and share data straight away, and share insights that can be explored, right? So you have all the big important advantages that you can leverage there with Tableau Server. They are true for the cloud in general, right? It's managed, it's very scalable. Everything that Michele showed, you can switch it on or off. So it's very flexible and you pay for what you use. That's a huge difference to the traditional data centers. And Airbnb, for instance, they run an operations team, or they used to run an operations team, with just 5 people. Everything in AWS, they were managing the whole infrastructure, over 1,000 nodes on AWS to support their website and their services. Tableau is running on AWS. As I mentioned, since a couple of weeks, we have our own pod now in Europe. So if you want to have run Tableau online, you want to be close to your data sources in the cloud, definitely deploy on that AWS pod in Europe. All right, so we want to install Tableau Server, we want to deploy Tableau Server. This is what you get, a big spectrum, a very colorful spectrum of different instance types, right? And I want to share a bit of our best practices in terms of which instance types are best to use and what to look out for, right? Obviously, you have to meet the hardware or recommended hardware requirements for a productive environment, for instance, and you have to be aware that AWS is mentioning virtual CPUs. That is actually, you have to actually halve them to get the proper hardware CPUs, right? So if you have an instance that has 16 virtual CPUs, you have to halve that, then you have an 8-core, for instance, with 16. Azure actually does it differently. They quote the proper hardware CPUs. And then you have, I would narrow it down to 3 major instance types for a Tableau Server use case. So we have one that is very compute optimized, a very strong processor, but a bit weak on the RAM, weak on the memory, right? Then we have a memory optimized, very strong, exactly the opposite, very strong on the RAM, a bit weaker on the CPU. And then we have a general purpose instance, which is trying to balance that out. So that's why I would recommend as well to get started with the M4 in this case, or the M5, which is a newer one. And it's relatively cheap as well compared to the memory optimized one. That's a good starting point. And then you have 3 different deployment options with Tableau Server and AWS. Number 1 is the AWS Marketplace. It's very, very simple. You basically select Tableau Server simply within an app store maybe, and you can deploy it within minutes. It doesn't give you the full flexibility. It doesn't let you install any other services on top of that or decide on the Tableau Server version to use. So it's a bit inflexible there. And then you have the self-employ, right? Just imagine you basically rent a server of AWS and you can do everything with it that you want. You add it to your network, you go to tableau.com and start installing it and start running it. So that's what I wanted to show you briefly. All right. So I need to duplicate this now.
Wait. That's the trick you taught me.
It's magic. Can you see that now? Okay, perfect. So if you go back to the management console at the start, right, where we have all the services, the key bit that we're using here is the compute and then the EC2 instance, right? That's the key service on AWS really to run infrastructure. So you select that, and then you can start selecting. You first see the dashboard, what instances are running at the moment, and you can launch new instances. So we have already a Tableau Server running on AWS, but let's go through the step-by-step. So we can choose the operating system, Linux or Windows, right? We can deploy where we want. Let's pick Tableau Windows Server for this purpose. And here are the different instance types now, right? So this is where our recommendations are coming in to get started with. So we have the general purpose ones here, right? So M5 is fine, M4 is very good as well. bit cheaper, but really look into the cores here. So 16 cores ideally for a productive environment, and you have 64 gigs of RAM. So that's perfect to get started with, and for most Tableau use cases.
Anybody knows why 16? Why Marius was actually looking for 16? Yes. Because of production, the minimum requirements for Tableau server are 8 physical cores that correspond to 16 virtual CPU.
Exactly.
In
Perfect.
Amazon.
Perfect.
Thank you.
Yeah. And then we can add it to a subnetwork, to our on-premise network. Very important as well, you can add storage here, right? You need at least 50 gigabytes, what we recommend. So just add double to it just to have some buffer there as well, to have some headspace. So you can add 100 gigabytes, for instance. You can add some tags, that's just for searching, for organization. And then you can add security groups. Here's just one thing you have to add, that's the HTTP.
That's the most important thing if you're self-deploying server on EC2, actually.
Exactly. That's the key bit, because behind the curtains, Tableau server is a web server, right? And that it's listening on port 80 by default, and you have to make it accessible to the internet at that point. And then we can review it, and we can start launching it, right? So we just choose your key here, and we can start launching it. That's already then launching up the instance, right? We don't have to go through the whole process actually. Oh, actually, it's the rules.
Yeah, but don't launch it because it's my credit.
All right, it's your money, right? It's your personal money. All right. So let's not launch that straight away. And if we then, so that was the self-deploy. That's basically it. Then you have the instance running. You go to tableau.com and you run the normal server installation, right? You have the full flexibility. Do you want Active Directory connected to it or local authentication? You have the full flexibility, and that's the big advantage there. So I would recommend going for a general purpose instance there. As I said, M4, a great starting point. 16 CPU, 64 gig of RAM, and a disk space, 100 gigabytes or more, right? Then we have some quick starts as well. So if you search for Tableau server quick starts, you have some
Pre-deployed.
Yeah, pre-deployed. Let's say templates to run Tableau server in a best practice environment, right? So if you search for AWS, Tableau, and Quick Start, you will find an overview of the different quick starts. You can run a whole cluster straight away with one of the deployment builds that you can use here. So you have the choice between a single node instance or here even a full cluster, and this is where all the best practices are already built in. You have a load balancer, you have an internet gateway, and it's already secured, right? So you don't have to think about these elements, and you can take those these templates and adjust it to your needs as well. So that's really very powerful.
No one prevents you to self-deploy this. It's just a quicker way to do it, essentially.
Yeah.
Correct me if I'm wrong.
That's correct. Good point. And then if we have a quick overview, so with self-deploy, you have the full flexibility, right? You can upgrade it anytime. So the Tableau server, you can upgrade anytime you want. You can add new services to it. You can scale it. You can add more storage and so on. You have the same with Quick Start. Beside the Active Directory is not built in there. You have to do that manually, and then with Marketplace you just lose a bit of that flexibility. So it's great for a POC, for a testing use case, if you want to quickly run and install Tableau server, share some content and try out how it works. Right, for this it's great. Otherwise, for a real production environment, I really recommend a self-deployment or using one of our quick starts guidelines and templates. So quick summary. What we went through, and then the key bit really is we have that Tableau server now, right? We deployed that, and we want to use all the analytics that Michele showed us, right? So let's try that out. So this part is, so the server here is already deployed in the cloud on AWS. We can just log in and finally have the analytics. In this case, we are connecting live to the Redshift. Should be able to see that here as well, right? We're connecting live to the Redshift and running analytics on scale on AWS, right? It's fully interactive. It's sending the queries to the Redshift, and we can share that with everyone in the organization straight away, right? This is a public domain, and we can add users to it and share content and share the data with everyone in the organization, right? So we went through the whole process, connecting to data, building views, and then sharing that on the Tableau server in the cloud. So everything is in the cloud now, right?
Yeah. So actually, this uses the data, the real data that we saw from the beginning. So when we did the first dry run of this presentation, it was about 2 hours and a half. And so we had to cut a lot of parts. But essentially, that end result uses Redshift that's populated through Hive using S3. So that's the whole story. So just as a conclusion before we move on to questions. So recap, we saw this. Analytics, S3, Athena, EMR, Redshift, and the Glue data catalog. This is all that we saw today. And these are, well, of course, EC2 in the infrastructure, so 6 in total. There are 6 among probably almost 1,000 services, like hundreds of services. But with just these services, you can build quite a comprehensive data pipeline from the collect part to the consume part. So these are just for you to get started. Of course, there are more specific services, but these are already a good start. So takeaways, don't want to spend too much time on this, but AWS is easier than it seems. Essentially, how I like to describe it, the learning curve, it's just knowing where to click. That's it, because it's all through the web interface and it'll just work. You just have to know where to find the different options. We work very well with AWS. We have a strong partnership. We actually work very well together on many scenarios. And Tableau server can run on AWS. You have the proof with Tableau Online that runs on AWS as well. And if you look back at the abstract, if we convinced you, then you can sell your servers on eBay. You can make some money. There are some servers on eBay that are worth 60,000 pounds, 50,000 pounds. So these are actual servers that you can find on eBay. So yeah, that's an option. Where to get started? Tableau.com/solutions/AWS. There's a page for Redshift as well, for other solutions as well. And if you want to try AWS, there's a free tier. So if you go to aws.amazon.com/free, you can try many services for free actually, and that's quite good if you want to get started with S3 and Redshift, etc. Now, remember to fill out the survey. It's really important. Yeah, and we accept suggestions for the next time. Questions?
Questions?
Yeah.
Any questions that make sense for everyone?
No? Okay, not for now.
You guys are available for questions.
Yeah, you're not actually, because you have to run another.
I have to run to my next session.
Yeah, but I'll be.
Next week we can
Yeah, of course, yeah.
Sure.
Yeah. Yes?
What decisions or what was you taking into consideration when regarding data volume and data velocity?
Yeah.
When deciding on your AWS analytics platform?
I think that depends. So the question is, how do we decide on which services to use, I guess, based on...
New York taxis.
Yeah.
It's fairly slow.
Yeah.
If you've got
Yeah.
in S3.
Yeah.
Yeah.
So yeah, so if I have a massive amounts of files coming into S3, that depends, I guess, a lot on the use case as well. So I'm just assuming it's interactive analysis, like with Tableau.
So you've got, say it's financial data, you've got traders who want to see
Yeah.
close to real time.
Yeah. So if they want to see close to real time and they have CSV, you can, I mean, what you can do, because Hive does batch processing, you can use something like Lambda, for instance. We didn't cover it today, but essentially it's a serverless service for running functions triggered by events. So you can have a trigger, I don't know if it's available, to be honest, but every time that a new file comes in, you trigger a load into I don't know, Redshift, for instance, or you trigger a transformation into Parquet, and then you can schedule a triggered load of Redshift of these Parquet files through Spectrum. I don't know. I'm just brainstorming because there are so many options. But if I were you, maybe I would have a look at the different architecture.
Sure. Okay. So that's if I put a solution in place now, that's a good idea from now into the future. Use, for example, Lambda. If I've got the same data, historical, going back years.
Yeah. Oh, okay. Well, you have to do batch loading at some point.
Would you say, okay, so would you say Parquet and
Yeah. So I would say seeing the format of the data, if it's clean or not, because I mean, eventually I would load it into Redshift some way. So if it needs processing, you can try and use an ETL tool. You can try to use EMR, but eventually put it into Redshift.
is there anything you recommend for JSON?
For JSON, again, depends. You can, yeah, you can load into a data warehouse if you want to. Yeah. So if you want to access the JSON directly, you can do it through Athena. That's a good way. But eventually, I would always try to store it back to a Hadoop.
That's fine. I'll stop.
Based. Okay. I'll remain here anyway. So if you guys want to come ask me questions, I'll be here around. Okay.